Let's see some examples on plane mirrors. We have a plane mirror, and this plane mirror is at rest. In front of this plane mirror, we have an object, and this object is moving towards the mirror with velocity v. Now the question is, image which this mirror forms of this object, it will also move. Now once it moves, you need to find velocity of image with respect to ground observer. Velocity of image with respect to ground observer. And in the second part, you need to find velocity of the image with respect to object itself. What I'm asking you is that, suppose you are standing in front of this mirror. If you are standing in front of the mirror, what is the velocity of your image as seen by a ground observer? And the second part, what is the velocity of your image which you yourself see in this mirror? These are the two things we need to find. You can pause the video and try to attempt this question and then come back and see the solution. So, good question for board examinations as well as for NEET and JEE, and it's very easy also. Look at the first part. Mirror is at rest, object is moving in this direction with v, image is moving in this direction with velocity v. Or you can do what? You can use a statement like this. Let's say initially distance between object and the mirror is what? D. If this is D, then we already know that distance of image from the mirror will also be what? D. At the very beginning, that was the situation. Then, after time t, you found that object is now at this new position. Let's call this new position O dash. If this is the new position O dash, then we are saying that image now occupies this new position I dash. That's the new position. This is the old position, let's call it O. Old position of image, let's call it I. Now, from O to O dash, object takes time t to move, and therefore, distance moved from O to O dash will be v into t. Distance is what? Speed multiplied by time. This is v into t, which means now distance left between new position of object and the mirror is what? D minus vt. Therefore, this distance between mirror and new position of image, it should also be what? D minus vt. Suppose we had no idea what is this distance I dash, then we'll say what? This is D, this is what? D minus Vt, and therefore image also moved a distance of what? Vt. In what time? T, and therefore and therefore velocity of image as seen by ground observer. Why ground observer? Ground observer found that image was at this position, and then after time t he finds that image is at this position, and therefore in time t image has moved a distance of what? Vt. And what is speed of an object? Distance traveled divided by time, which is what? V, divided by time, which is t. This gives us V. If somebody says find out velocity of image with respect to ground observer in vector form, velocity of image with respect to ground observer in vector form, you can simply say minus of V for this direction. Now this is what? This is velocity of the image as seen by ground observer. If they ask this question in board examination, then you can proceed like this. Show initial and final positions, and then say that in time t, object has moved Vt. Initially distance is d, and then we are using the property what? Distance of object from the mirror and distance of image from the mirror. They are always what? Same if it's a plane mirror. After time t, this distance is what? D minus Vt. This much distance is left, d minus Vt, and therefore distance between mirror and new position of image is also what? D minus Vt. If this is d minus Vt, then we found that this distance must be Vt. This Vt is traveled in time t, and therefore speed of the image as seen by ground observer is coming what? V. Negative sign is for direction. Now, for velocity of image with respect to object, we can use two things which are basically identical. I hope you remember this formula. You have seen this formula in relative motion. Velocity of A with respect to B. Velocity of A with respect to B is given by velocity of A with respect to ground observer minus velocity of B with respect to ground observer. That's the formula for relative motion. If I say that find out velocity of image with respect to object, then using this direct formula we can do what? Velocity of image with respect to ground observer minus velocity of object with respect to ground observer. Now remember one thing, when you write velocity of image with respect to ground like this, V, velocity of object with respect to ground, question says that object is moving with what? Velocity V. If you do this V minus V, then you will get 0, which is wrong, because velocity is a vector term, and therefore when you are using this formula, make sure you use things with proper sign. Proper sign means like this. What is velocity of image with respect to ground? Minus of V. If you wish, you can use minus of V I cap, but left means minus and right side is what? Plus. Minus of velocity of object with respect to ground, which is V towards right, and therefore V, giving you minus of 2V. Minus of 2V means magnitude is what? 2V, and direction is what? Left. This object is moving this way. Sorry, the image, its velocity as seen by the object, its velocity as seen by the object itself is of 2V magnitude and is towards left or towards the object itself. That's how you can find this velocity using the formula of relative motion. Or you could have done the same thing which we did with this Vt and Vt part for the first method. Look here. How do you define velocity? Velocity of image as seen by this object. It means what is the distance traveled by the image in time t as seen by the object. Look here, what I am saying. Initially, an object is at this position, image is at this position. Distance between object and mirror is d, and therefore distance between image and mirror, that is also what? D. After time t, object is at this new position, image is at this new position, and we know that this distance is now d minus vt. This distance is also what? Same, d minus vt. This is d minus vt. This is also what? D minus vt. Now, how do you find velocity? Fundamentally, at t equals to 0, initially, what was separation of image from the object? Because we are interested in what? We are interested in finding velocity of the image as seen by the object, and therefore we'll go for the separation. So at t equals to 0, if you ask this object, what is the separation of image from the object, then it will say that separation, let's call it S, that separation is what? 2D. D and D. Now, at time t, if you ask this object, now look, at time t, object is no longer at this position. Object is at this position, which is what? O dash. And if you ask the object, what is the separation of image at time t, then at time t, this new separation S dash is 2 times d minus vt. D minus Vt plus D minus Vt. Now, I hope everybody knows this thing, that when you write V, you write what? ds by dt. What is S? We will say displacement. Yes, it is. But ds means rate of change of separation. If we go for magnitude part as of now, because we already know the direction, ds upon dt means what is the change in separation. The change in separation is what? Initially it's what? 2d, finally it's what? 2 times d minus vt, and therefore this ds is 2d minus 2 times d minus vt. What is this? ds. What is ds? Change in the separation from 2d to this, divided by in what time this change in separation took place. That time is what? T. 2d and 2d cancelled, negative positive, you get what? 2v. The magnitude part is coming what? 2v. And then this observer will say, or object will say that as separation is decreasing, definitely image is moving towards the object itself. It looks very descriptive in this form, but in few questions you will see later on that this technique is also very useful. Otherwise, as far as this question is concerned, where mirror is at rest, things are quite obvious. Object is moving with what? V, and therefore ground observer will simply say image is moving with V. If you move towards a mirror with velocity V, then velocity of image as seen by this thing definitely is 2V. Note down this, and then we'll see next example a bit level up. Note down this much. Now look at this next example. Mirror, which in the first example was at rest, but in this second example, this mirror is moving in this direction with velocity V. This is your object, and this time round, object is at rest, and we need to investigate behavior of image. We need to find velocity of image for ground observer. Velocity of image for ground observer. That's all. There is no need for velocity of image for the object, because you can see object is what? At rest. This object is equivalent to ground observer. Object is equivalent to what? Ground observer. The ground observer finds that object is at rest. Ground observer finds that mirror is moving towards the object with velocity V. We need to find velocity of image as seen by that ground observer. And remember, object this time is equivalent to ground observer. Pause the video, try to find this thing, and if possible, find out a link between this example and the previous one, and then come back and see the solution. Now, let's go with the detailed version first, and then we'll see the trick part. Object, image. Let's say this is the setup. This is the setup at t equals to 0. At t equals to 0, ground observer finds that this distance is d between object and the mirror, and therefore this distance is also what? D. This is the initial setup. Now at time t, what happens? This mirror now occupies this new position. This is at time t. This is at time t. At time t, from this position to this position, mirror is moving with what velocity? V, and therefore this much distance is simply what? V into t. Mirror is moving with V. In time t, it travels Vt distance. Therefore, new distance between object and mirror is this much. What is this? This is d minus Vt. D minus Vt. And therefore, if ground observer finds that image at time t is at I dash, remember this time object is at the same position. Let's call that this is M for mirror, and this new position, let's call it M dash. For new position of mirror, ground observer says that image is at I dash. But you know that this much distance between mirror and image should be same as that between object and the mirror. What is that? D minus Vt. And therefore, this thing is also D minus Vt. D minus Vt, D minus Vt. Now, look at this. This is D. This much is Vt. And therefore, from this position to this position, look at these alignments. Look at these alignments. This and this is what? D plus this much. What is that? Vt. This is coming D plus Vt. And how much is this? D minus Vt. Which means distance moved by the image. Distance moved by the image as seen by ground observer is D plus Vt minus D minus Vt. D plus Vt minus D minus Vt. Now how much is that? This is coming, D and D cancel. This is coming 2Vt. Ground observer finds that image has moved a distance of 2Vt in what time? Time t. And therefore speed is what? Distance divided by time, which gives you what? 2v. If you're looking for direction, you can see that direction is what? Minus of I cap. This is the first method with the help of the basic approach of finding speed, which says find out distance traveled in time t, divide that distance by time, and you will get what? Speed. This is a very fundamental approach. But we could simplify this question, and if you look at this question in this form, then I hope you can realize its link with the first example. Look at the question. Original question is that mirror is moving in this direction with V. Here lies your object. O for object. Object is at rest. And we need to investigate velocity of image as seen by ground observer. Now, in the first example, this mirror was at rest. Object was moving in this direction with V. And it was quite easy to find this, that image therefore should move in this direction with velocity v. Something which is quite easy. Mirror at rest, object is moving in this direction with v, image is moving in this direction with v. This is what we found in example 1. And then in the second part of this example, what was the second part? Second part was that what is the velocity of image as seen by the object? Now you already know that answer. That answer is what? 2v. That answer is what? 2v. Look at the link of this and this. In this question, we are aiming for what? Velocity of image of the object as seen by ground observer. Ground observer finds that mirror is moving. In here, what we found that if you ask this observer, which is the object, if you make this object an observer, then remember one statement from relative motion. Observer is always at rest. Observer is always at rest. If I ask you, what is your velocity right now? You will say that it's zero. Because as an observer, you find that you're not moving. But we all are sitting on what? Earth. Earth is moving, and therefore, along with Earth, we all are moving. But still, if I ask you what's your velocity is, you will say you are at rest. Same thing happens with this object. If you ask this object, what is its velocity? It will say it is at rest. And we found in first example that if object is at rest, and mirror moves with and if object is at rest, then image moves with what? 2v velocity. Now this is 2v, this 2v is the velocity of image, but look at the link now. This mirror is at rest. For whom? For ground observer. If you ask him, this mirror for him is moving in this direction with velocity v. Look at this part. Suppose this is the mirror. If this is the mirror, this is the object. Keep the mirror at rest. Object moves in this direction. That's what is happening in first example. But if you ask this object, in this example only, you will say that it's not moving. What is moving? Instead, mirror is moving towards the object. Same thing which you see when you are inside a car or inside a train. When you are inside a train, for you, train is at rest. The trees by the side of the track, they are instead moving in the opposite direction. That's what is happening. This passenger finds that the tree is moving in the opposite direction. So, object is at rest. Mirror is moving with V. And what did we find in example 1? In this situation, image should move with what? 2V. This image, therefore, should move in this direction with what? 2V velocity. That's what you got. That's what you got with the help of detailed analysis. Hopefully समझ में आ गया होगा किस तरह से इन questions को आप handle करते हैं. Now, look at the trick part again. This trick we can again utilize in this form. Look here. Mirror. The approach of relative motion. We can use it with the help of simple figures. Original question is that mirror is moving in this direction with velocity v. Original question is that object is at rest. And we need to investigate velocity of the image. Now do what? What we know is this. This is something which is very easy to remember. If mirror is at rest and object moves, it's very simple to imagine that image is also moving with velocity v. Now let's make this mirror at rest. Let's bring it at rest. How do you bring it at rest? Give it a velocity in this direction. If you give this mirror a velocity in this direction of what v, then what happens? V and V cancelled. Mirror comes at rest. Mirror comes at rest when you superimpose this V. But remember, you need to superimpose this V to the object also. Mirror is moving in this direction. To bring it at rest, we gave it a velocity in this direction, but give that same velocity to the object also. Now, when you superimpose rest and V, what is that which you get? What is that which you get? You get that the object is moving in this direction with V. Rest and V together. That gives you what V. This is equivalent to what? This V. Rest. In this case, you already know that. Okay, image therefore must be moving with what velocity? V. Then the question is that this thing is extra. You supplied it extra. You have found this thing. You added this V so that you can bring this mirror at rest. But originally, mirror is not at rest. And therefore, do what? Let's go back to the original question. If I give this mirror this velocity back in this direction, then V and rest together. This mirror starts moving in this direction with what velocity? V. If I give it V, then I must give that same V to this object. What happens? V and V, they both are cancelled. V and V cancelled, you get what? Rest. But if you give this V, then this image should also be given same V. That's your image. Hopefully you can see the answer. Image is now moving with what? V plus V. That is what? 2V. That's a trick. A very useful trick. You don't have to draw anything like this. If you get confused with this, again leave it. Simply use this method. We'll see another application of this method in the third example. For now, just note down all the three methods. Now look at this example. We have a mirror. This mirror is moving in this direction with a velocity of 3v. This is the object. It's moving in this direction with a velocity of, let's say, 2v. Now this time round both are moving, object as well as mirror. Aim is to find what? Velocity of image as seen by ground observer. Then velocity of image as seen by the object itself. Velocity of image as seen by ground observer. Velocity of image as seen by the object itself. Now you can pause the video. Either you can use the descriptive method, show initial position and position after time t, and then find out separation and all. That's a very lengthy approach. Let's not go for that. Instead, I recommend that you use the trick part. If you use the trick part, it will be very easy for you to understand this question and solve this question also. And then come back and see the solution. The only thing we know is this. If you want to use a trick, you just need to remember this part. If mirror is at rest, object, if it is moving with V, then image also moves with same velocity V. That's what we know. Now, this mirror is moving with 3V. If this mirror is moving with 3V, let's bring this mirror at rest. And to bring it at rest, give it 3V in this direction. If you gave 3V to this, give this object also same velocity of 3V. There is no point in giving 3V to this image because we have no idea with what velocity image is moving. And once you do this, this system is now equivalent to what? This whole thing, This whole thing is equivalent to what? Mirror which is at rest. 3v and 3v cancelled. Mirror is at rest. Object is moving in this direction. 2v plus 3v is what? 5v. Image. Now, you can relate this figure with that, something which you already know. If object is moving with 5v and mirror is at rest, then image must also move with 5v towards the mirror. Now, once you found this, you can do what? Return this 3v back. You had given 3v to this, you had given 3v to this, but let's now return these velocities. Now how do you return? This thing is moving, is at rest. Give it 3v in this direction. Give this object 3v in this direction. Give this image 3v in this direction. Once you do this, this whole thing is equivalent to what? This whole thing is now equivalent to what? 3v and rest together. This mirror is moving in this direction with 3v. 5v and 3v. This object is moving in this direction with what? 2v, which was the original question. 2v and 3v. That was the original question. But we have found velocity of image as seen by the ground observer now. What is that? 5 plus 3, which is coming what? 8v. This is the data for ground observer. And therefore, we have obtained this velocity as what? 8v. Now, let's go for velocity of image with respect to object. One thing you can do what? You can use that relative velocity formula, and relative velocity formula says this: velocity of image with respect to object is velocity of image with respect to ground observer minus velocity of object with respect to ground observer. Velocity of image with respect to ground observer is not 8v. Remember, this is vector equation. Minus of 8v. Minus velocity of object with respect to ground is what? 2v. This gives you what? Minus of 10v. You can use directly the formula, or you could do this. I told you that when you write like this, velocity of image with respect to object, then this thing is object but is now observer. When you write velocity of image with respect to ground, ground is observer. When you write velocity of image with respect to object, object is observer. And observer is always at rest. Now the question is, find out velocity of image as seen by this object. But if you make this object an observer, then it must be at rest. Now what should I do for that? It's moving in this direction with 2v. Let's give it 2v in this direction. This 2v and this 2v, they both will cancel each other. Ultimately, this object will be at rest. But if you gave 2v in this direction, then do the same with all these things. 2v, 2v. Hopefully, you can see the answer. This setup is now equivalent to what? Your mirror is moving in this direction with 5v, although we do not need that. 3v plus 2v. This object is at rest. If it is at rest, then this is the observer for this figure, and image you all can see is moving with 8v plus 2v. This is what? 10v. 10v. This trick of adding and removing these arrows, it's a very useful trick for any question like this. You just need to remember, what? This part. Note down everything. Let's see how image formation takes place when we have got two mirrors. We've got two plane mirrors and they are placed like this, perpendicular to each other. This is mirror 1, this is mirror 2. They're like this, two plane mirrors perpendicular to each other. An object is placed at the angle bisector. That's your object. When you say that object is at the angle bisector, it means you're talking about symmetrical position. Object is at symmetrical position. Symmetrical means at same distance from M1 and M2. The aim is to find number of images formed by these two mirrors. This combination, how many images does it produce? We need to find that. This is a very easy method, and let's see that easy method first. Let's extend these mirrors like this. If this distance is d, then you can see that this distance is also d. That's what it means when you say symmetrical position. This mirror 1 will now form an image of this object right here. This is I1. At what distance? Same distance d. This distance is what? D. And since this distance is d, this distance will also be what? D. Let's show this distance also. This is also d. What is I1? Image formed by the mirror 1 of this object. Now, let's see this M2. When you look at M2, at the object behind the mirror M2, you will find the image. That's I2. Again, you can see that this distance is d, this distance is also d. And since this height is d, this height must also be d. Now, what is I2? Image formed by M2 of this object. What is I1? Image of object formed by M1. And you all know that if object is real, which it is, then this image should be virtual. What is I1? I1 is virtual image. I1 is virtual image of object. Let's call this object O. I1 is virtual image of object O formed by mirror 1. In short, by M1. I1 is a virtual image of object O by M1. Similarly, what is I2? I2 is virtual image of object O made by mirror M2. Now look at this I1 again. This I1 is behind M1. It's what? An image. But this I1, I hope you can see, is in front of M2. Is in front of M2. If it's in front of M2, mirror M2, then for M2, it behaves as an object. This I1 is object for M2. In front of the mirror, and therefore this thing becomes what? An object. In the second part, when I will explain the ray diagram, you will understand this point with much more clarity. But as of now, use simple arguments. If this is in front of the mirror, object. This I1 is an object, but for this object M2, for this object I1, you must have an image. Where do you form that image? At same distance D, behind the mirror, right here. At this location, you got what? I3. At what distance? D. Since this is also D, we know that this is also D. What is I3? What is I3? I3 is image. I'm intentionally leaving these spaces, you will see later. I3 is image of what? I1 made by which mirror? M2. Which mirror? M2. Now, this I1, which is a virtual image, I1 which is virtual image, is now a real object. How do you define real? If things are in front of the mirror, then they are what? Real. This I1 is in front of M2 and therefore is what? Real object. This I1 is behind M1. Behind things are what? Virtual, and therefore I1 is what? Virtual image. This is something which is very important for any examination. You talk about board, NEET, JEE, anything. These small points, they're very important, and therefore look at these points carefully. If you don't understand them right now, you will learn this thing better when I use the second part, when we develop the whole thing with the help of ray diagram. But as of now, things which are behind the mirror are what? Virtual. Things which are in front of the mirror are what? Real. Now I ask you, what is I3? If I ask you what I3 is, you will say that M2, I3 lies behind it, and therefore this I3 is what? A virtual image. Virtual image of I1 made by the mirror M2. Now, what is left? This part. What is I2? Virtual image. Why image? It's behind the mirror made by the M2 mirror of this object. But this I2 at the same time you can see is in front of M1, and therefore I2 is I2 is what? An object. What type of object? In front of the mirror, things are what? Real. It's a real object. I2 is real object. Real object for which mirror? M1. I2 is real object for mirror M1 because it's in front of M1. This I2, which acts as an object for this mirror, therefore mirror is going to form its image behind at same distance d, and therefore right at this position, you get a fourth image. Let's call it I4. What is I4? This I4 is what type of image? I4 is virtual image. Why virtual? Because it's behind the mirror M1. It's behind mirror M1. I4 is virtual image of look at this, real object. I4 is virtual image of real object. What is that real object? I2. I4 is virtual image of real object I2 made by which mirror? M1. In all, how many images you see? 1, 2, 3 and 4. But since 3 and 4 they coincide, they form at the single position, same position, ultimately you see what? A single image, and therefore in all how many images you see? 3 images. This is what a standard answer. You can remember that answer as a result. Whenever you have two mutually perpendicular mirrors, total number of images, if you place an object, the angle bisector is what? 3. That number is what? 3. This is something which is very easy to remember, but something like this. This is a bit conceptual. Try to feel it with that part where I explain what is the meaning of real and virtual. If you are unable to understand what real and virtual are, go back and see that lecture. You will understand it. But look here again. What is I1? This I1 is real object for M2. Now, for this M2, this is the real object. This I3 is virtual image. This I3 is virtual image of I1. Now, what is I1? I1 is what? This I1 is what? Real object, and therefore you must write real object. I1 made by mirror M2. Just slow down this and you will understand this part with the help of second approach. Now you will understand the meaning of real and virtual with the help of this ray diagram. Look how easy it is, but with the help of ray diagram. How do you define object? Object is what? Intersection of incident rays. And how do you define image? Intersection of reflected rays. Things in front of mirror are real, behind virtual. Just remember this thing. This is the position where object is present at that point. What happens? You need to form a case of reflection. For that, you must have two rays. If you want to form an object, if you want to form an image, you must have what? At least two rays, because intersection, that will give you what? Position. This is the first ray, and then that's your second ray. Now, before you start reflecting these rays, if you remember, I had given you an advice that locate position of the image first. If this is D, at same distance D, draw this image I1. And then do what? And then do this. From this image, join this line, join this point and continue. From this image, join this point and then continue. And then continue. And then do what? And then do this. Now, when you start reflecting these rays first, then many a times it becomes difficult to produce them backwards and let them meet at the same point. This and this. Now let's understand real and virtual with the help of this. What are these two things? These are incident rays. They are falling on this mirror. They arrive at the mirror. Intersection of incident rays gives you what? Object. This object is in front of M1, and therefore O is real object for M1. O is what? Real object. Now, what are these two rays? These two rays are reflected rays. They are moving away from M1. Intersection of reflected rays gives us what? Image. But this image lies behind M1, and therefore this I1 is virtual image. I1 is what? Virtual image of real object. I1 is virtual image of real object O for mirror 1. Very simple. Reflected rays. How do you define? How do you identify reflected rays? They move away from the mirror. Away. Intersection takes place behind M1. Therefore, virtual image of this real object made by this mirror M1. But now look at the important part. These two rays, they are what? These two rays are incident rays for mirror M2. How do you define incident rays? Incident rays, they arrive at a mirror. These two rays, they are what? Incident rays for M2. If these are incident rays, intersection of incident rays gives us what? Object. And therefore, this I1, the same I1 is object. Intersection of incident rays is what? Object. And where does it lie? Behind or in front of M2? You will say in front of the mirror. In front of the mirror, things are real, and therefore I1 is real object for mirror 2. This I1 is real object for M2. Now what? Now, again, that's too fast. This is I1, approximately right here. form I3. I1, I3. Same distance behind this. Now, this is I3. Do what? From I3, join this point, continue. From I3, join this point, continue like this, and then do this, and then do this. Nothing can exist behind the mirror in ray optics. This is I3. What is I3? These two are reflected rays. Reflected rays, they are moving away from M2. These are reflected rays, the intersection is what? Image. This I3 is an image. But this image lies behind M2. Things behind M2, things behind the mirror are what? Virtual. So this is virtual image. Of which object? Of this object. This object is what? Real. I3 is virtual image of real object I1 for which mirror M2. This I3 is the virtual image that lies behind of real object I1 incident rays. This I1 is what? A real object. Reflection takes place at M2 and therefore things are for M2. That's what we did in the previous part. That's how you take advantage of this ray diagram and all. Now, a little exercise for you. Do the same thing yourself for I2 and I4. And if you don't understand it, take help from this part. Hopefully, you will understand everything. Note down this much.